Let's get started with having the computer do the tedious part, the drudgery of the linear algebra. The language I've picked for this is called Sage. It's designed for doing mathematics in, sort of symbolic mathematics like algebra, linear algebra, lots of other stuff. I also picked it because you don't have to buy anything. You don't even have to download anything. If you go to cocalc.com, you don't even have to sign up for an account. You can just click Run Cocalc Now, and voila. Here we are. So it's going to dump you into a notebook, which is how it stores information. And we want to pick which kernel we want. We want the Sage Math kernel. There's obviously other kernels. If you do any programming ever, this is a really nice resource. All right, so it starts a new Sage worksheet. And the thing about Sage is it starts off as the world's best calculator. So let's say I want to find something out like 2 plus 3. Okay, to evaluate, if you hit enter, you get a new line. That's no good because it doesn't actually do anything. But if you hold down shift and hit enter, that evaluates. So you can see it took that line of input, and now it's going to give me some output. After a while, the first execution of any command when you open a new notebook is always slow. Don't worry, it's not actually that slow. If we do 2 plus 3 now, it's basically instantaneous. So you can do arithmetic. Well, that's not very interesting. Sage knows about variables, so you can name things. I could say I want A to be 3. I'm going to use that regular enter, not the shift enter. B to be 5, and then I'm going to ask Sage, hey, what's A plus B? Now I evaluate, it says 8. And Sage remembers what A is. So if I say, what's A? Well, it tells me it's 3. You can also do things like evaluate. It knows about functions, like the sine and cosine. Of course, sine of 3 is not a very interesting number, but I could ask what is sine of 3 times pi, and it's 0. What else can you do? So you can assign variables, like give things names like a, b, etc. You can also define what are called symbolic functions. That's mathematical functions as we know them. For example, you could say, let's let f of x be x cubed. Okay, that's a definition. It doesn't do anything, but then you ask Sage, hey Sage, what's f? And the answer is f is a function that takes in x and sends it to x cubed. Notice this notation is reminiscent of some pretty standard mathematical notation. And then you can ask it things like, what's f of a? 27. Okay. Now, that is symbolic functions or mathematical functions. The only variable that Sage knows about to begin with is x. So sometimes we want other ones, like let's say we wanted to have t and y and z and capital X and q. Okay, that's how you tell Sage that those are going to be variable names from now on out. And now you're allowed to do things like, I'm going to define g of t and y is t plus y. Let's see, what kind of a thing is g? G is something that takes in a pair and spits out a number. So we could ask, what's g of ab? And the answer is 8. The other thing that Sage knows how to do is to differentiate. So for example, let's say we want to differentiate this function f. You differentiate a function, you get a function. Notice the type is right. It sends x to 3x cubed. And then if you wanted to, you could evaluate that. You could say, what is diff of f? What's the derivative of f? If I plug in a, and the answer is 27. Sage can also integrate. To integrate, you have to tell me a function, and you've got to give me some bounds. So let's say I want to integrate f of t from t equals 0 to t equals 3. Takes a little bit longer because that's symbolic integration. The answer is 81/4. You can also integrate entirely symbolically. So integrate, let's say f of t from t equals 0 to t equals x. And there you go. Notice you get a function back. Okay, so it can differentiate, it can integrate, it knows how to define functions like we think in the mathematical sense, and it knows about variables.